Hi there, you are tuned into Maths with AD. Today's lesson is on geometric pattern. Now, geometric patterns has to do with shapes or objects, and you can get a whole variety of geometric patterns by using different shapes and different objects. Alright, in this case, my geometric pattern that I have in front of you is made up of matchsticks. And if you look even closer, you would see that these matchsticks are placed in such a way that they form triangle. Did you notice that? Yes, triangles is all about shapes and matchsticks as well. Alright, and therefore it's called a geometric pattern. Now, in this particular geometric pattern, you are either required to count the number of matchsticks in each term, or sometimes the number of triangles in each term. If you look at the table below the pattern, you would see that in this pattern we are required to count the number of triangles. Right, so we are not counting the matchsticks today, we are counting the number of triangles for this pattern. Okay, the question asks us to draw the fourth and the fifth terms for this pattern and also to find the rule for this pattern. Okay, now in order to draw the fourth term and the fifth term, we need to find a pattern in this pattern. We need to look carefully at what is given. Now what is given is a series of 3 terms. That is what is given. We're going to work with what is given. We have to find the pattern on how this pattern is changing, and then only we can draw the fourth and the fifth terms and we can find the rule for this pattern. Okay, now let's look at the pattern carefully. The first thing you should be noticing about this pattern is that it is a growing pattern. Okay, now if you look at term 1, right, in this case we are not counting the matchsticks, we are counting the triangles. In term 1, I see that there's only 1 triangle. In term 2, I see that there's 1, 2, 3, 4 triangles. Okay, now look carefully at term 2. You see 1 triangle on the top. You will see 2 triangles below. But these 3 triangles on the outside are placed in such a way that it forms the 4th triangle in the middle. Right, at a glance you will just see 3 triangles, but if you look closer, you would see that these 3 triangles actually form the 4th triangle, which is in the middle. Okay, right, now if you have noticed that, very good. Okay, and then going on to term 3, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 triangles in term 3. Now, I've already filled in the number of triangles for term 1, 2, and 3 because these terms have already been drawn for us. It's already given. Now, before I move on, you would notice that I'm calling it term 1, term 2, term 3. You could also refer to it as figure 1, 2, 3, 4, and 5, or diagram 1, 2, 3, or pattern 1, 2, or 3. Anything you want. Okay, it means the same thing. Term 1 is referring to the first picture. This entire pattern is made up of these different terms. Okay, and it's not just the first picture that is the pattern. It's the entire, all these terms put together to make up the pattern. Alright, so in this pattern, the first 3 terms have already been drawn for you, and we're going to work with what is drawn to figure out the difference, what is changing, to find the pattern in the pattern. Okay, now let's start. The first thing you should notice that this pattern is a growing pattern. It's increasing in size. Right, you should be able to see that first. This pattern is increasing in size as we move from term to term. The number of matchsticks that's used in each term is also increasing. And by increasing the number of matchsticks, adding more matchsticks each time, we are also increasing the number of triangles that is being formed in each term. Okay, so term 1 got a few matchsticks and only one triangle. Term 2 got a few more matchsticks in term 1 and more triangles. And it goes on and on in that pattern. Okay, now let's figure out what else we notice before we draw term 4 and term 5. Okay, if you have noticed that term 1 has only one row, term 2 has 2 rows of triangles, one on the top and one below. Term 3 has 3 rows of triangle, 1 row, 2 rows, 3 rows of triangle. Okay, that is very important. It's an important piece of information, and it's going to help us to know how many rows there's going to be in the 4th term and the 5th term. So term 1, 1 row, term 2, 2 rows of triangle, term 3, 3 rows of triangle. So in term 4, there should be 4 rows of triangles. All right. And how many rows of triangles do you think is going to be in term 5? That's right, 5 rows of triangles in term 5. Okay, now let's see what else we notice. We have to find out every single detail of these patterns. We work with what is given, and if we can find a pattern with what is given, it's going to be very easy for us to find the number of triangles in any term possible. Okay, now look carefully. Term 2 looks like a repetition of term 1. If I take term 1, these 3 matchsticks put together, which forms one triangle, and if I place it on top of term 2, that makes up my first row. Can you see that? Right, so that one triangle, the one triangle from term 1 is the top row of term 2. And we have added the second row. All right, we have added the second row now. Okay, what's happening? We have added the second row to make an additional 3 triangles. Okay, so there's 3 triangles in the second row. There you go. So the first term is the same as the top row in term 2. And 3 more triangles in the second row. Together, 1 triangle plus 3 triangles makes up 4 triangles. All right, did you notice that? Very good. Now, what else do you notice from term 2 to term 3? If I take term 2, and if I place it on top of term 3, I would notice that the first and the second row of term 3 is very much similar to the first row. The first and the second row of term 3 is very much similar to term 2, which is 1 triangle right on the top and 3 triangles in the middle row. Okay. Now that makes it even easier. Now we are getting somewhere. Right, so if I take term 2 and place it on top of term 3, all right, it looks very much similar. And in addition to term 2, we have 1, 2, 3, 4, 5 triangles now in the third row of the third term. Okay, now we are getting somewhere. Look carefully at, we have now discovered that this geometric pattern can be changed into a number pattern. Okay, and we are following a sequence in this number pattern. Did you notice what the sequence is? Look carefully. 1 triangle in the first row, 3 triangles in the middle row, 5 triangles in the third row. We are following a sequence of counting in 2s in odd numbers, 1, 3, 5. Okay, we have 1, then we have 1, 3, then we have 1, 3, 5. Will that be of any help when we are drawing the 4th term? Let's see. We have said that the 4th term should be a repetition of the third term. So if we take a copy of the third term and place it like somewhere around there, all right, it's the same as term 3. It's the same as term 3. There's 3 rows. Okay, but now we need to add an additional row of triangles. And how many triangles do you think we are going to add at the bottom? Right, before we do that, let's see how many triangles are there in the first row. 1. In the second row, how many triangles? 3. In the third row, how many triangles? 1, 2, 3, 4, 5. Okay, we said we're following a sequence, a number sequence, as we are adding triangles in each row. So what do you think is going to be our 4th row? Our 4th row is going to be made up of 7 triangles. And if you guess 7, you are brilliant. Okay, so we are following a sequence of counting in 2s in odd numbers. 1, 3, 5, 7. So now we need to add 7 triangles to make up the 4th row for term 4. Right, and let's take the 7 triangles. If I take these matchsticks and place it underneath term 3, I would now have drawn term 4. Okay, just how it's supposed to be. Now, if I want to know how many triangles there are in term 4, you could do one of the following. You could count the triangles individually, 1, 2, 3, 4, 5, 6, 7, etc. You could add 1 plus 3, which is 4, 4 plus 5, which is 9, and 9 plus 7, which is, can you tell me? 16. All right. Okay, and that's how we can get our answer. Or you could notice another pattern. Now, we are going to notice the pattern by looking at this table. Before I draw term 5, I can actually tell you how many triangles are going to be in term 5 just by working out a pattern that we see in front of us. Now look carefully. If I look at term 1, right, as I said, term 1 is picture 1. Term 1 has 1 triangle. Term 1 has 1 triangle. Look again. Term 2 has 4 triangles. Look again. Term 2 has 4 triangles. Term 3 has 9 triangles. And after drawing term 4, we have figured out that term 4 has 16 triangles. Do you see a pattern from the term number to the number of triangles? If you have seen that 1, if I multiply it by itself, 1 times 1, I get 1 as an answer. If I take the 2 from term 2 and multiply it by itself, 2 times 2, I would get 4 as an answer. And if you take 3, term 3, the 3 from term 3, and multiply it by itself, 3 times 3, you should get 9 as an answer. So 4 times 4 is 16. Now I can tell you how many, there's a pattern to follow, and I can tell you how many triangles there should be in term 5 without actually drawing it first. I would use the same rule that I have used for the previous terms, which is the term number multiplied by itself. So 5 times 5 is 25. There you go. So I have figured out how many triangles in term 5 without drawing it first. All right. Now, if you look to your right, you would see another way of working out the rule for this particular geometric shape. Right. As I have written here, the term must be multiplied by itself, and we can write it as term squared, term number squared. So if my term number is 1, and if I square it, it means 1 times 1. If my term number is 2, and if I say 2 squared, then it means 2 times 2. If I say 3 squared, it means 3 times 3. Alright, so 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. As I told you, these output numbers were already given. The number of triangles were already given because we have counted them according to the diagram that has already been drawn. So term 4 is 4 squared, which means 4 times itself, and that means there's 16 triangles in term 4. And term 5 is 5 times itself, which is 5 times 5, or 5 squared, which is 25 as an answer. Okay, so we have figured out our rule. Right, and now to draw term 5. We said term 5 should be a copy of term 4. So if I take a copy of term 4 and place it in term 5, okay, I need to add an additional row. Term 4 has 4 rows. Term 5 should have 5 rows. So I've got 4 rows because of term 4, a copy of term 4. I need to add a row below it. Right, which makes my 5th row. And if I add that 5th row below it, I now have term 5 drawn for me. Right, and if I want to check to see that term 5 has 25 triangles, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Or you could simply say term 4 has 16. I needed to add 9 more triangles. I needed to add 9 more triangles because each time I'm adding triangles, counting in odd numbers. Right, so this 4th term has 7, and the last row should have an addition of 9 triangles. There you have it. Okay, 1 plus 3 is 4, plus 5 is 9, plus 7 is 16, and 16 plus 9 is 25. All right, if you look at the bottom, you would see also 1 plus 3 is 4, 4 triangles plus 5 is 9, 9 plus 7 is 16, 16 plus 9 is 25, 3, 5, 9, 3, 5, 7, 9, etc. Okay, now we're going to move on to a different example. All right, this also requires you to count a number of matchsticks or triangles. In this case, if we look at the bottom, we see here we have to count the number of matchsticks as we go from term to term to term. Right, we are also required to draw the 4th term and the 5th term and to find the rule of this pattern. Alright, now because we are counting the number of matchsticks, remember we are not going to count the triangles that are inside, that are formed by these matchsticks. We are going to count the number of matchsticks. Now I've already filled in, there's 5 matchsticks in term 1. Because these diagrams or these terms have already been drawn for us, it's easy to count 1, 2, 3, 4, 5. In term 2 I have counted 7 matchsticks. In term 3 I have counted 9 matchsticks. Right, now we need to find a difference. What is the difference as we move from term 1 to term 2? Term 1 has 5. What is the difference from 5 matchsticks to 7 matchsticks? That's right, we have added 2 more matchsticks. So 5 matchsticks, right, term 1 is a repetition of term 2. Term 2 is a repetition of term 1. Okay, with an addition of 2 extra matchsticks. Term 3 is a repetition of term 2. So if I take term 2 and place it on top of term 3, I would say 3. Alright, there's 3 triangles there. Okay, and if I add 2 more matchsticks to it, that makes up term 3. So I added 2 more matchsticks to term 2 to make up term 3. Alright, so 5 matchsticks in term 1 plus 2 more makes up 7 matchsticks in term 2, plus 2 more makes up 9 matchsticks in term 3. So what do you think I should add? How many matchsticks should I add to term 3 in order to make up term 4? That's correct. I should add 2 more matchsticks to 9. So if I take term 3 and I place it in term 4 and add 2 more matchsticks to it, this is how it's going to look. Right. There's term 3 there with 2 more matchsticks on the side, and 9 matchsticks plus 2 more is equal to 11. Right. And then if I take term 5, I'm going to repeat term 4. Right, I'm going to repeat term 4. There you go. I'm going to repeat term 4. But in addition to term 4, I have added 2 more matchsticks on the side. And 11, because term 4 had 11, I'm just going to add 2 more to 11. And that's going to make 13 matchsticks in term 5. All right. Now, if I look at my flow diagram, how am I going to figure out my rule for what I have done? Right. Now, remember, each time we move from term to term, we have added 2 more to the previous term. 2 more matchsticks to what was in the previous term. If there were 7 matchsticks in term 3, we added 2 more matchsticks to term 3 to make term 4. And 7 plus 2 is 9. 9 plus 2 is 13. 9 plus 2 is 11, and 11 plus 2 is 13. Okay, now if we are constantly counting in 2s, we are adding 2 each time to go to the next term, we need to know that adding 2, repeated addition of 2, requires you to know your 2 times table. So the first part of my rule is to multiply my term number by 2. Okay, because I am adding 2 matchsticks each time to move from term to term. All right, so my term number, which is 1, if I multiply it by 2, I would get 2 as an answer. 1 times 2 is 2. However, I need to have 5 matchsticks in term 1. So I have to do more to this rule in order to end up with 5 matchsticks. At the moment, 1 times 2 is 2, which means there's only 2 matchsticks. I need to add more to this rule. So if I'm going to say 1 times 2 is 2, I need to add 3 more to 2 to give me 5 matchsticks altogether. Can you see that? Right. So my rule now is not just a single sum. Right, it requires 2 operations. I first have to take my term number, multiply it by 2. Right, the reason why we multiply by 2 is because we're consistently adding 2 more each time we are moving from term to term. And then I needed to add 3 more so that I could get my required output. Right, now 5 is already given. It's not a number that I would just guess. It's already given. Term 1 has 5 matchsticks, so I needed to increase my rule so that I end up with 5 matchsticks as my output. Now, this rule will only work if it works for term 2 and term 3 as well. Okay, we cannot use this rule if it only applies to the first term. So let's check it out. If I take the 2 in term 2, if I take the 2 and multiply it by 2, the answer is 4. And 4, if I add 3 to it, I end up with 7. So it works for term 2 as well. Does it work for term 3? If I take 3 multiplied by 2, the answer is 6. And if I take 6 and add 3 to it, the answer is 9. So this rule works for term 1, 2, and 3. And if it works for term 1, 2, and 3, then you are safe to say that this rule should work for any term number. Alright, so let's take 4 in term 4. Let's take the 4 multiplied by 2. Your answer is 8. And 8 plus 3 is 11. That's correct. And if I take 5 from term 5, the term number, which is 5, multiplied by 2, that gives me 10. And 10 plus 3 is 13. Okay, 10 plus 3 is 13. Okay, so now I have worked out my rule. I have drawn my fourth and fifth terms. Alright, and I have filled in the number of matchsticks in the 4th and the 5th term as well. Now, boys and girls, before I do the next example, I need you to know that this rule can apply for any term number. So if I want to know how many matchsticks are used, for example, in the 10th term, okay, in the 10th diagram of this pattern, I would say 10 times 2, which is 20, and 20 plus 3 is 23. So in the 10th term, I'm going to be needing 23 matchsticks. Okay, and you can work out any term, even if this pattern has 100 terms in it, you would be able to work out how many matchsticks are needed in those terms without drawing each term individually. Okay, right, let's quickly move on to the third and last example. Okay, the third example now is a pattern, a geometric pattern that is made up of dots. Okay, look carefully. First, we had geometric patterns made up of matchsticks. We were required to count the number of triangles and not the matchsticks in the first example. In the second example, we also had a geometric pattern made up of matchsticks, and in that case, we were required to count the number of matchsticks in each term. Now, in the third example, we have a geometric pattern that is made up of dots, and we have to find out how many dots there are in each term. Again, we are required to draw the 4th and the 5th term and also work out a rule. Okay, now this case we are going to do it slightly different. Before we draw the 4th and the 5th term, we are going to work out the rule first. Okay, so let's look at our pattern. Let's work with what is given. In term 1, we have 1 dot. Okay, and that's already filled in for you because it's from what is given. In term 2, we have 5 dots. All right, 5 dots. But notice that term 2 has that same 1 dot that is from term 1 in the middle. Can you see? If I take that 1 dot from term 1 and I place it in the middle, okay, and then if I add a dot on each end of my arrow, okay, north, east, south, west. Okay, I am adding 4 more dots to term 1 in order to give me 5 dots altogether in term 2. And if I take term 2 and place it on top of term 3, I notice that there's 5 dots in the middle, and then an additional dot is added on each end of your cardinal points, north, east, south, west. How many dots does that make up altogether? All right, remember now we are adding 4 dots to term 1 to make up term 2. So 1 dot plus 4 dots give me 5 dots. Then we have 5 dots in the middle plus 1 on each end. So that's 5 plus 4. That should give me 9 dots. All right. Okay, and if you count it, you would see the 1 dot in the middle. There's a 1 dot in the middle, and this time we have 2 on each end. We have 1 dot in the middle and 1 on each end. We have 1 dot in the middle and 2 on each end. So what do you think term 4 is going to be? It's going to be 1 dot in the middle and how many on each end? That's right, 3 on each end. Okay, right. Now let's work out the rule first before we draw term 4 and term 5. From 1 dot, we are adding 4 more dots to give me 5. From the 5 dots, we are adding, what's the difference between 5 and 9? That's right, 4. So we're adding another 4 dots to 5 dots to give me 9 dots altogether in term 3. Now, look at the pattern. We are adding 4. We are adding another 4. So we should continue to add 4 to get the rest of the patterns. Now, as I said, if you are adding 4 repeatedly, you should know your 4 times table. So the first part of your rule is to multiply your term number by 4. Now, if we have term number 1, 1 times 4, you should get the answer of 4. However, in term 1, I only have 1 dot and not 4 dots. So I need to do something else to this rule in order to end up with 1 dot. I need to extend this rule. 1 times 4 is 4. What will I do to 4 to end up with 1? That's right. I should minus 3 from there. Now, it's not final until the same rule applies for at least 3 terms in a row. So if I take term 2 multiplied by 4, 2 times 4 is 8. And 8 minus 3 is 5. So the rule applies for term 1 and term 2. Now we need to make sure, so we're going to check it out with one more term. 3, term 3. 3 times the 4 is 12. And 12 minus 3. What is 12 minus 3? That's right, 12 minus 3 is 9. And as you can see, term 3 has 9 dots. Okay, so now by using this rule, we can figure out how many dots term 4 has. By taking the 4 from term 4, multiplying it by 4, 4 times 4 is 16, and 16 minus 3 is, what is 16 minus 3? 16 minus 3 is 13. That's correct. Right, and then we take the 5 from term 5, multiplied by 4. What is 5 times 4? 20. And what is 20 minus 3? 20 minus 3 is 17. Okay, so we are saying 1 dot. Okay, in term 1, there's 5 dots in term 2, there's 9 dots in term 3, there should be 13 dots in term 4, and there should be 17 dots in term 5. Okay, we can also fill those numbers in our table, which is on the left. Okay, now to draw the dots. We said term 4 should be a repetition of term 3. Right. In addition to term 3, we need to add 1 dot on each end. We need to add 4 dots altogether to term 3. Alright, so as we are moving, we are continuously adding 1 dot on each end to get the next set of dots. Okay, the next term. So we've got now 3 dots on each end of the middle. Alright, if we take the middle, there's 2 dots on each end. If we take the middle, there's 3 dots on each end. And if we count in threes, 3, 6, 9, 12, plus the 1 in the middle, we get 13. And there we have it, 13 dots in term 4. Term 5 should be a repetition of term 4. Right, term 5 should be a repetition of term 4. In addition to that, if you look at the blue dots, there's 1, 2, 3, 4. 4 dots added to term 4. 1 dot on each end of your cardinal points, north, east, south, west. Okay, and if I look at the number of dots on each end, I would say there's 4 plus 4 plus 4 plus 4. That's 4, 8, 12, 16. Plus the 1 in the middle, 16 plus 1 gives me 17. And there are 17 dots altogether in term 5. And boys and girls, that is how we continue to draw our next terms. Alright, for each geometric pattern, you can use the table to figure out your rule, or you could use the flow diagram to figure out the rule in order to draw your next term. Now, by drawing this flow diagram and working out what the rule is, you can work out the number of dots for any term that you want. So for instance, if I want to know how many dots there should be in my 100th term, all right, how many dots there should be in my 100th term, it's going to be 100 times 4, which is 400, and 400 minus 3. What is 400 minus 3? 397. So in my 100th term, okay, my 100th term, which means my 100th picture, using the same pattern, I should have 397 dots altogether. Now this is very interesting stuff. I hope you enjoy the lesson and hope to see you soon.